Hi guys, welcome to chapter 2 of Math 135. So we are starting a new chapter, and anytime you start a new chapter, a lot of times, that first section is kind of like an easier section, which I think is kind of the case here. This is section 2.1 about quadratic functions. And the good news is quadratic functions are something we've seen before, we're a little familiar with. In fact, it was one of our faithful friends, if you remember, when we had that library of functions section back in chapter 1. So this is a little bit of review. There's some new stuff here a little bit too, but a lot of review. Okay, so let's just get right into it. What are we learning today? Number 1, how to write a quadratic function in vertex form. And along the way, we'll also learn what standard form is. And number 2, how to graph a quadratic function and interpret its graph. We've actually learned about graphing these things before. Remember, the graphs are those parabolas, those U-shaped looking things, and then sometimes they're upside down U's if the coefficient is negative in front of the x squared term. Okay, let's look at topic number 1, how to write a quadratic function in vertex form. First, we're going to look at what is standard form. Standard form is kind of like the most standard form you could write something in, right? So look at this thing. Here's standard form. And what do you have here? You've got all your terms just basically expanded. So this is what you'd get if you were to multiply your terms out, multiply all your values out, and then just list them in decreasing order of power. So the x squared term is first, then the x term, and then the c term. Here the coefficient is a, here the coefficient is b, and here it's just a number c. B and C could both be 0 possibly, but here A should never be 0. And the reason is if A is 0, then this x squared term disappears. And the x squared term is what makes it a quadratic function. If there's no x squared term, then we wouldn't call it a quadratic function. So A should not be 0 if we're going to call it a quadratic function. And the same thing here. Yeah, same reasoning there. Okay, the second part, this is vertex form. So vertex form, it's called vertex form because hidden in the form is a vertex. And that vertex is right here at HK. So H is the x coordinate and K is the y coordinate of the vertex. If just really quick visually, the vertex, normally a parabola looks something like this. Vertex is that spot right at the very bottom. Or if it's opening downwards, it's that spot right at the very top. Okay, now how do you go from one to the other? So let me mention briefly, if I'm in vertex form, and I wanted to get back to standard form, it's actually super easy. All you do is just multiply everything out. So you would FOIL this whole thing, then you multiply by the A, add the K, and just, expand everything out. Then you have standard form, basically. The other way is a little more tricky. To get from standard form to vertex form, what you basically want to do is complete the square. Right? And we've done some completing the square before when we transformed remember circle equations from standard form, or actually we made it into the standard form for circles. So we did some completing the square before, and it's essentially the same process, but there's also a little cheat way. The cheat way is to note that the vertex is actually right here, negative b over 2a and f of negative b over 2a. That gives you your h and k values. So you can kind of cheat, jump straight to the chase here. Here's your h, here's your k, and once you have those two things, then you just go back here and just plug it into this format. And then you have your whole thing. You're straight already. Yeah, so simple as that. Let me give you a quick justification. I'm not going to do the entire completing the square process, but I'll just kind of show you the start of it to see where this comes from. The important piece is here, this h piece. Where'd that come from? So let's say I started with f of x equals ax squared plus bx plus c. Well, what would you do to complete the square? First thing you do is you take out this a, because we don't like to deal with a coefficient, right, of that a. So I'd have a times x squared, factoring out the a, I mean. And then since I factored out the a, the second part should be b over a, so that when I multiply the a times that, the a disappears. That's over the x. And then the c I'm going to leave separate, because I'm focused on completing the square part with the x terms. And then I have to add something here to make it a perfect square, right? And that thing that I would want to add is it's going to be a b squared over a squared. But don't worry too much about that. That's just the thing that's going to make this whole thing into a perfect square. Okay, on this other end, I have to subtract some stuff, because I introduced this adding thing. So I have to subtract something as well. I think that's the correct term. But don't worry again too much about that. Right here, I really want to just focus on the completing the square part. So this portion here, that would become, and that's the complete square part. And how do you complete a square when you have something like that? Remember? Well, you take half of this thing and you make that the center portion, right? Because you're going to end up multiplying by itself twice. You're going to get double of those. That's what gives you back that thing. So what does it become? It becomes half of that. So b over 2a. So this is x plus b over 2a. and then this whole thing squared. So right now, this whole portion right here, that became x plus b over 2a. So that's the kind of the critical step. And if you look at that thing, that b over 2a looks a lot like what we have here, right, for the x coordinate. The only difference is, you notice over here, up here, this was a minus. So if I was to convert the forms to look similarly, I could rewrite this as x minus negative b over 2a. And that's the same as x plus b over 2a, right? So here's where that term came from. Okay, and that's squared. And then you'd pull that a down, you'd pull all this stuff would come down here as well. But I really just want to focus on that one portion here. This is the negative b over 2a part. Okay, that was getting a little ugly. I just wanted to give you a quick justification for where it comes from. We just really got it from completing the square. But now that we have it, let's just use it and abuse it. So here's what we have. That was such a dorky thing to say, use and abuse it. I don't know where that came from. Anyway, so the x coordinate, or the h part, is this negative b over 2a, right? And then that's the x coordinate. If you want the y coordinate, you just take that negative b over 2a and just plug it back into your function, because that's the y coordinate, right? So you take f of whatever that negative b over 2a was. That gives you the k portion, or the y coordinate of your vertex. Okay, one easy way to remember this is by just remembering the quadratic formula. And the quadratic formula is something that I think a lot of us might have already remembered from, sorry, just checking my battery, from high school. It's kind of a common thing that people remember. The quadratic formula is right here to jog your memory. It's x equal to, and there's like a little jingle that goes with it. You may have learned negative b plus or minus the square root of b squared minus 4ac all over 2a. I'm singing that terribly, but something like that. So sorry guys, I'm just butchering that little tune. But that's what it is, right? Negative b plus or minus square root of b squared minus 4ac. And looking at this thing, that quadratic formula, if I was to just erase the square root portion of that, so this is plus or minus b squared minus 4ac square rooted. If I was just to take this whole thing out, black that out. So all I did was take out the square root portion. Look what you're left with, negative b over 2a. And that is exactly what your h coordinate is. So easy way to remember that, if you already know the quadratic formula, take out the square root portion, you have your h coordinate. And then from there, k coordinate, like we mentioned earlier, you just plug it back into your function. Now you're gonna see all this in practice in the next video. I'm gonna cut out this video because this video is it's gonna get too long, I think, if I do everything all together. So this video will kind of just be introducing the chapter and the theory behind questions 1 through 8. And then in the next video, we'll tackle the next questions. All right, see you there.